Hello everyone, welcome back. It's Beginner's Java, lesson number 21, I think. Okay, as many of you know, I've been spending my time working in the private sector now as a Java developer, and I spend my time basically doing rubbish. But it has given me some good insight on the things that I've missed and the things that I should probably teach now that we're getting a bit more into the advanced side of Java. In C++, I went and I showed a lot more about, file outputs and things of that nature. Whereas with this, I'm going to be showing, more how to break things up into projects, how to include files from other projects, how to, deal with, other people's libraries, things like that, because I think that that's going to be more applicable, especially with Java. Um, because with Java, it's almost frowned upon that you sort of use your own code if there's better existing code out there. I mean, why make your own XML parser if there's already, SAX and DOM and XPath and, parsers for all of them? So, we're going to be getting more into that in the coming lessons, but for now, I actually want to talk about primitives and class wrappers and things of that nature. So, as many of you have probably found out by testing, this is something you can't do. So you can't do double D equals null. You can't do that. It tells you requires a double, found a null type. So let's assume that you end up with something like this. You do double D and you say if, and let's say you have int k equals 5. Let's say if k is less than 5, d is equal to 10, and then your else has nothing to do with d. Your else is, k plus equals 10, whatever. So now if we run this program, and then at the end we try to do system.out.println d, and then we just do plus k. So we'll do like that. So d, this keyboard is not made for coding. New laptop. Plus. And you'll notice that this won't even let me compile. It's going to say D might not have been initialized. I know D might not have been initialized. So what can I do in this case? I can set D equal to 0, but that's really an imperfect solution because if I set it equal to 0, what if it's possible that I need this data somewhere else and 0 is a valid result? Now, I could set it to something that's unlikely to come up, like negative 999.987. But even still, let's say I'm dealing with, something that can have any number or any double value in a wide range. If I disregard this value, it's possible, however unlikely, that I could disregard a real value. So assigning this some kind of crap value is really not good. So if I just leave it as 0, sure, it'll compile, but it will, stay as 0 here. So I mean, I kind of end up with this sort of desire to, you know, program around this when I can. And it's funny. I was in a work meeting. I have a coworker. He's excellent coder, but he has this sort of problem where he where he just kind of knows how to code everything if it's difficult, but if it's easy, just he doesn't know the basics. So he came to this problem. He said, "Well, what if you get a null value?" And this is in a meeting. We had a one-on-one meeting, and he said, "Well, what if you get a null value?" And I said, "Well, you use a double." And he goes, "But double can't accept null." And I was like, "Yes, it can." And so you'll notice that if I just try to assign double to null, it can't. So it would appear as though I'm wrong. However, this is where what are known as class wrappers come in. Now, double D like this is a primitive. However, double D with a capital D is no longer a primitive. So now, in this case, the only thing that would have to change in this program to make it act properly is changing that to 10.0. So now, since k is less than 5, that's not going to trip. And let's see what happens now. So we end up with null being output for D and k being equal to 15, unlike earlier where we had to set it arbitrarily to 0. This also gives us a few major advantages over using the primitive double. So for example, if I type if and then I say D double equal sign null, I can test for that now. And so then I can, maybe run it through some kind of a check. Or let's say I'm using a MySQL statement. I can then say, like stmt dot, whatever, and do that to set null. So if it goes into a database, I get to set it as null, so it's not looking for a double. So, all those things are important, but this just gives you a little bit more control over the way that your variables are handled, which at the end of the day is really what you're trying to control in a program. So with that being said, let's skip on to another sort of idea that I have not presented. And I suppose the idea that I haven't really presented at length is sort of changing values from type to type. And this is something I run into hundreds of times every day. In just this program right here called DEFCON Update, that's one of my main work projects, I think I use toString about 20 times, toInteger and toDouble, just as many times. And it's very, I spend most of my day just converting data from one type to another and pulling data from one place and then getting it to the way I want it and then sending it somewhere else. So, a lot of, working in Java is understanding what type of data you're dealing with and how to pass it off and how to move it. So, let's assume that we have a double again. So double D equals 4.0. Okay, but now let's say that we have a method down here that only accepts a string. So let's call this a public static void, let's say append oh hi, and it's going to take in a string, and that string will be named str because I'm not very, you know what, let's make it return a string too. Okay, so now it's just going to return str. And so let's say we wanted to have this 4.0. Let's just pretend that was passed back to us by some other method. Let's say we wanted to have that 4.0 pass through this append oh hi, which is going to do exactly what you think it is. So str equals str plus oh hi. Okay, so, but if we just try to pass in the D, I mean, obviously that's really not going to work. So we can't say D equals append oh hi D. That's not going to work because it's going to tell us, you got the wrong type. Well, it says, shorty, you're not my type, whatever. Anyways, so we need to make a string. Or we could skip that and do something a little bit more convoluted, but let's make a string. So what we're going to do is we're going to say str equals, and then we're going to say d dot, or I'm sorry, str, wait, it should be append oh hi dot d to string, like that. Why am I not remembering the string command? Okay, well, first things first. You need to be like that. Is that? Oh, yeah, right. Double dot to string D. That's what it is. Sorry, I was kind of fumbling over myself a bit there. So then we'll just do system.out.println D. So as you can see, I'm using the class wrapper double to wrap our normal double and have it output a string. So we give this a run and we get 4.0. Now, what could possibly be the reason for that? The answer is a little tricky. Number one, we're setting this value. Number two, we're outputting D. So if we change that to output what we actually want, we get oh hi, which I suppose is what everyone wants, is a nice warm greeting. So, okay, what have we covered? We have covered doing things to string, and by the way, you can do this to double, amongst other things. Don't be that way. Okay, so let's say str dot to double, or something. Double dot parse double, I'm sorry, str. In that case, it could be 5.0 or something like that. And that would then do it that way. And then there's integer dot parse int, and there's one for basically every primitive. And in time, we'll be getting into how to do that with files and things of that nature, and how to serialize things properly, and yada yada yada. But for now, I think that's going to wrap it up for this one. I'm going to talk a bit about inheritance, and hopefully it's going to be a bit more cognizant than this video was. Just kind of blowing the dust off with this one, so hopefully you guys have enjoyed this. Have a good one.